Hello everyone. Today I will talk about my article comparison of IDS in IoT, mobile and cloud-based systems. First of all, let's me briefly talk about myself. I'm Görkem Gök, a graduate student at Fırat University and also research assistant at the Software Engineering Department of the Faculty of Technology. Associate Professor Mustafa Ulaş and Associate Professor Aytu Boyacı advised and supported me in this study. The aim of this study to examine how intrusion detection systems and network monitoring technologies are evolving in various technological environments, computer systems, cloud, IoT, and mobile area. It compares methods to protect against cyber threats through innovative security solutions and tools. Intrusion detection systems are software or hardware-based tools designed to detect malicious activity or policy violations on computer networks or systems. These systems are used to identify abnormal or suspicious activity by monitoring and analyzing traffic and detect security breaches at an early stage. In this way, they help prevent or limit potential damage. Now that we have made the general information, we can move on the details of my article. I built on three different structures: computer and cloud-based systems, mobile device, and industrial IoT. On the computers and cloud-based systems and industrial IoT side, I carried out my work in three titles: intrusion detection system, traffic monitoring and analysis techniques, data integration and central database management approaches in network traffic monitoring and analysis techniques. While I carried out my work in two titles on mobile device, there is no data integration and data central database management approach in network traffic monitoring and analysis techniques titled in the mobile area. A total of 10 studies were analyzed under the main heading of computer and cloud-based systems and compared under their subheadings. Under the title Intrusion Detection System Studies for Computer and Cloud-Based System, three studies were analyzed. Their comparison is as follows. Ali et al.'s works, a specific algorithm is developed to improve intrusion detection systems. The study emphasizes on refining the algorithm used in IDS. P. Ghosh et al. Aimed to enhance IDS capabilities in a single system by integrating various machine learning methods. This integration focuses on the use of various machine learning systems within IDS. Mode and Petal aim to better combat security threats by adding IDS to existing classification methods. The study emphasizes the augmentation of complex classification systems with IDS. Under the title Studies on Network Traffic Monitoring and Analysis Techniques for Computer and Cloud-Based Systems, four different studies were analyzed and compared. Comparison are as follows. Suji et al.'s study focused on enhancing cloud monitoring by utilizing existing methodology, specifically, specifically emphasizing cloud monitoring techniques. Saye et al.'s research provides a general exploration of monitoring in software-defined networking, covering both theoretical innovations and practical applications with a focus on SDN technologies. Abbas et al. Study examines the role of deep learning in network traffic monitoring and analysis, aiming to enhance security monitoring capabilities through the use of deep learning technologies. Shin and Gu's research introduces a novel application of OpenFlow technology to address security challenges in dynamic cloud network environments, emphasizing the use of OpenFlow in security monitoring. Under the title Data Integration and Central Database Management Approach in Network Traffic Monitoring and Analysis Techniques, three different studies were examined and compared. Alonso et al.'s research provides an overview of how big data principles can be applied to enhance network traffic monitoring and analysis. It emphasizes big data principles and data management techniques. He and key studies focuses the application of big data technologies to create an integrated platform for optimized network traffic analysis. It highlights the use of big data technologies and integrated analysis methods. Türk Papa et al.'s research developed INTEP, a proprietary framework specially for local area networks. that integrates various systems to manage and analyze network traffic more efficiently. It emphasizes proprietary framework development and land management. A total of 9 studies were analyzed under the main heading of industrial networks and compared under their subheadings. Under the title of Intrusion Detection System Studies for Industrial Networks, 5 studies were examined and the technologies they used were compared. U et al. Study focuses on using deep learning models to detect specific types of cyber threats, highlighting the application of deep learning technology in cyber threat detection. Latif et al.'s research emphasizes the use of deep learning for detecting particular cyber threats, similar to study by KU with a focus on deep learning technologies. Yilmaz and Gönen's research provides a targeted approach to protect programmable logic controllers within industrial control systems, employing custom rule sets a primary technology. Gunjal et al. Study compares different neural network architectures to other state-of-the-art methods in terms of their effectiveness, focusing on neural networks as the key technology. Hong et al.'s research explores the for how federated learning can enhance anomaly detection and data management in industrial Internet of Things environments using federated learning technology. After that, networking traffic monitoring and analysis studies in IoT networks are examined. Their scope and technological approach are examined. Lavazani et al. Study explores the impact of telemetry data at the switch level on network performance, specifically aiming to improve network reliability and reduce performance issues. The key technological approaches used are advanced data analytics and AI in network solutions, with a primary application in network reliability and performance management. Wong et al.'s research develops a multitask learning algorithm designed to accurately predict irregular traffic flows, thereby enhancing service quality and network security. The study's technological approach involves multitask learning algorithms with a focus on traffic management and network security in SDN-enabled IoT networks. Finally, big data approaches in network monitoring and analysis techniques are examined in IoT networks. Rehman et al.'s study provides a comprehensive survey of big data analytics application in IoT, including a classification of relevant literature frameworks and case studies. The methodological approach taken is a survey and theoretical analysis of literature, with a key emphasis on strategic operations and potential of BDA to transform industries. Zhang et al.'s research introduces a sophisticated method that combines federated learning with deep reinforcement learning to optimize data management in IoT networks, particularly within wireless network. The methodological approach is practical and application focused, utilizing advanced algorithms with a key emphasis on providing operational solutions and enhancing data privacy. As our last topic, in intrusion detection and network monitoring techniques in mobile networks are examined. A total of 6 studies were examined in 2 topics. Under the title Intrusion Detection System Studies for Mobile Device, 4 studies are revived and their main contribution are compared. The Bog et al. Study developed solutions specifically tailored to the resource limitations of smart device using cloud-based frameworks. The main benefit offered is the reduction of resource demands on devices, enable them to perform better while relying on cloud resources for processing. Ribeiro et al.'s research focused on autonomous host-based systems that reduce the need for extensive collections of malicious samples. The approach minimizes the data processing on the device itself, enhancing device performance and security. Al-Rabi et al. Introduced privacy-respecting flow-based features for mobile traffic within intrusion detection systems. This approach enhance both privacy and efficiency by analyzing network flows in the way in a way that respects user privacy. Holmes Sutter et al.'s study utilized cloud emulation to perform comprehensive security analysis without taxing the processing capabilities of the mobile device. The approach of lots processing to the cloud, which enhanced the thoroughness and effectiveness of security analysis. Finally, network traffic monitoring and analysis techniques in mobile networks are analyzed. Their targeted results are compared. Schuba et al.'s study titled "End Monitor" concentrates on user privacy and data leak prevention by developing a tool named End Monitor. This tool uses extensive data and real-time analysis to prevent data leaks and enhance user privacy. It incorporates a rule-based classifier with high accuracy. The targeted outcome is improved user privacy in network monitoring. Aurora et al., although the study title is not specified, the research is focused on malware detection through network traffic analysis on the Android platform. It notably achieves this without requiring access to device internals, enhancing operational security. The key contribution is to increase security for Android device through efficient malware detection. The review highlights the importance of both traditional and innovative security methods in various competing environments to counter digital threats. It discussed the use of sophisticated algorithms and machine learning intrusion detection system to enhance security in computer and cloud environments. For the Internet of Things, it emphasizes the application of deep learning and federated learning to protect against cyber threats while maintaining data privacy and system performance. This research also points out that cloud-based and autonomous systems are vital for mobile security, helping to manage security challenges without overburdening the limited resources of mobile device. Overall, the review underscores the need for continuous innovation and adaptation in employing advanced technologies for effectively address specified security threats and improve the efficiency of network systems in a digitally interconnected world. Thanks for listening.